Good morning, everyone. This is Pat Sauer. I'm the Executive Director of the Iowa Stormwater Education Partnership. You are here for the fifth webinar of the Stormwater Design Series for 2018. I'm standing in for Ben Curtis, who's on vacation this week, and want to welcome you to the webinar. So today, we're going to take a look at the multifunctional aspects of green infrastructure and also look at community engagement. And with us today, we have John Royster and Ryan Bentley with Big Muddy Workshop. And they're essentially going to share a lot of information with us about adding function and value to green infrastructure practices and engaging community participation within green infrastructure practices. Talk a little bit about some challenging situations that they've worked with and how they've championed an integrated multifunctional design approach that essentially benefits the members of a community. A couple of housekeeping items. One is, if you could please use the chat section on your screen for asking any questions. And those questions will be answered depending on the length or scope of the question. They may be answered during the webinar, or the speakers, presenters will hold off until the end of the webinar. Also, to get PDHs, you could write your name in the chat box section to let us know that you will receive a certificate, or email Ben Curtis at bcurtis, C-U-R-T-I-S, at iowastormwater.org, and he will send you a certificate for your PDHs. So we will get started in about 1 minute here. Okay, I am now going to hand over the presentation to John and Ryan. So hold on 1 minute, please. Okay, John and Ryan, go ahead.
Well, good morning from west of the Missouri River this morning. We're in Omaha, Nebraska, and we're happy to be talking to our friends across the wide Missouri over in Iowa. I'm John Royster, and with me, as Pat said, is Ryan Bentley. Just 1 second. Sorry for that interruption. We both practice, we're both professional landscape architects practicing with a firm out of Omaha called Big Muddy Workshop. We're delighted to be able to have this time with you today because green infrastructure is one of our 3 passions. Our firm practices in the area of green infrastructure. That's about 1/3 to half of our work some years, and then we also do master planning and we do traditional landscape architecture. The first thing I'm going to admit today is that I'm the pretty face and probably the old guy on the conversation, but I have a Bachelor of Science degree in agriculture, which gives me a great science background, and then I did my master's at Kansas State. Ryan is truly our expert on green infrastructure. Ha ha. And no, Ryan is. It's been a delight to have Ryan with us for the last 10 years. We have done literally tens of millions of dollars of constructed value of green infrastructure, and we've got some really exciting projects. We're going to only be able to share a few of those with you today. But I think what's interesting is the genesis of today's topic is really the master's thesis that Ryan did at University of Georgia. And with that, I'll turn it over to Ryan.
So really quickly, this is our agenda. We'll go through these. We'll first go through multifunctional green infrastructure. So we'll go through definitions, why green infrastructure and multifunctionality, examples of multifunctional landscapes. and then goes through some of the benefits, the ecosystem services, the economic benefits. And then on the back end of the multifunctional green infrastructure, we'll talk about innovation, creativity, integral design, and collaboration.
And then I'll kind of pick it up at that point. Ryan's really going to do the heavy lifting on this, but I'll talk a little about community engagement, because having practiced landscape architecture for 35 years in the public realm, I've really gained an understanding and an appreciation for community engagement. And I'm going to kind of talk about how we've done it on some of the projects you're going to see. And then I'm also going to talk a little about the philosophy of community engagement as part of this. So Ryan, let's talk about your thesis.
So my thesis was essentially, the question I was asking was, what aesthetic design principles maximize use within a treatment wetland? So I was in Georgia. In Georgia and Florida, there are several large wetlands there that provide tertiary treatment after they've been processed in a sewer treatment plant. So engineers had laid out these very large, expansive wetlands, and they had never considered that people would actually want to use them. So it was really interesting over time, as people almost knocked at the doors of these places and said, let me in, because there's attractive habitat for waterfowl, and essentially most of the visitors were bird watchers, but it also just people wanted to be in these beautiful landscapes. And so that's kind of what triggered this. So some of these facilities kind of got it. To the lower right here, or to the lower left, that's the discharge point of one facility where they put a boardwalk right next to it. It's kind of an interesting feature there. To the top of the screen, there's a pavilion there that provides shade and the boardwalk through it. And then the lower right there, you can see the boardwalk system of this facility and how interesting with different spaces and different landscapes. It really is a very interesting place. And so some of them got it. Some of them, and then others, this shows an example of another pavilion, of a lookout area. This is the upper right picture, was a picture of when I was at that previous boardwalk, and there was a lot of people there. It was amazing. Also, informative kiosks, shade structures, and benches over the shade structures. That was one thing that we noticed, that you needed shade in those areas.
So one thing that a point I think Ryan wants to make is there are people that really get it, and then there are those that don't.
So this facility actually was in North Carolina, and I went to the place and I thought, oh, this is going to be great. And the lower right picture is what I saw, a big fence around the facility with a sign saying visitors must report. So I go to the office there to report, and they're like, what, you're a visitor? And I was curious, trying to ask them a bunch of questions, and they're like, we've never had a visitor here. And the upper left, you can't see it exactly, but it's overgrown, and the boardwalk hasn't been used. It's out of, its pieces are missing, and so some places didn't get it as much. And probably the best example that I saw was this nature center that was placed right adjacent, nearly into a wastewater treatment facility, wetland. This actually occurred as a second facility after the municipality had success with another project. And so this was after they had built on that success of the first project. They added and really integrated this into their solution. So it was a really awesome example of using a single purpose facility and then adding function into it. So on to definitions. Fun definition. So EPA's definition of green infrastructure is a cost-effective, resilient approach to managing wet weather impact that provides many community benefits. While single-purpose gray stormwater infrastructure is designed to move urban stormwater away from the built environment, green infrastructure reduces and treats stormwater at its source while delivering environmental, social, and economic benefits. I like this definition because it really plays into the multifunctionality angle that we'll talk about. So going on, gray infrastructure, it's interesting, the infrastructure itself, the definition means something down, below, or under, right? So that's something unseen, possibly unsightly, or possibly discarded. So some stormwater has often been placed underground to conceal it, and often to set it and forget it so the public don't see it. Large areas of land have been cordoned off, like this picture here, with a big fence for single purposes such as stormwater management and the storm surge, ocean surge, and water treatment. And so often gray infrastructure separates functions in the name of safety, which is good, but we can often do a little bit better on that. And then also temporary, stormwater usually is a temporary use of a land. And so we don't necessarily need to take a lot of land and only use it for one temporary use.
Although I think if you drive through a lot of cities in the Midwest, and I can think of a massive basin that's right off the interstate up in Sioux Falls, South Dakota, where that's really its only purpose. So I think what Ryan is saying is, as part of his thesis research, he started wondering if people were really doing things the way they could, or getting all the opportunities that exist in a facility. And with that, he kind of transferred his research from wastewater treatment facilities over to the green infrastructure field.
Yep. So just a quick, so multifunctionality, what is it? It's essentially functionally layered landscapes. Ian McCard, a landscape architect, he popularized this image over here. Essentially, he called it a layer cake map. That was done back in the 70s, and pulling out all of the different uses of a site and attributing the different environmental, economic, and social functions within a site.
So then the last thing we want to talk about here is community engagement. And having, again, done this for over 30 years, I think the really important thing is creating a meaningful opportunity. And I'm going to talk a little about that. At the end, we also needed to kind of separate sometimes stakeholder groups from the general public, and then just talking about why you're doing the project. So we'll hit this a little later in the presentation.
So why green infrastructure and multifunctionality? Why do they work well together? So multifunctional landscapes, it's a better use of land. When you aggregate uses, it creates synergy. I think we've all kind of got this within our cities. We talk about aggregation within downtown areas and how that works and how businesses generally thrive in downtown areas. The same thing is true with landscapes usually, if they're well designed. Landscapes that can be thoughtfully layered with several functions provide smart, economical use of land. Multifunctionality is the antithesis of like suburban sprawl. It's the wise use of land. So public access and visibility, green infrastructure, multifunctional landscapes allow the public to connect to natural systems in an urban setting. So areas that were previously cordoned off or can be recaptured and well utilized by the public with well-designed landscapes. And then multifunctional landscapes create setting where innovation and coordination can occur and do well. So we'll talk about these opportunities later in the presentation. So green infrastructure and multifunctionality, why do they work together well? So green infrastructure within the definition is treating stormwater with mimicking natural hydrology and using natural systems to treat stormwater. So this includes soils and vegetation which infiltrate, evapotranspirate, and recycle runoff. So when when rainwater is treated near its source, it creates a more condensed and manageable spaces to add functional layers to. When you treat things downstream, it's harder to do that. So green infrastructure too can be a connective, restorative, and land enhancing approach to designing and installing stormwater management. So water generally draws people in. That's one of the things as landscape architects that we constantly think about. And then natural systems shouldn't be disregarded. So in-pipe systems or end-of-pipe systems often try to hide and set and forget, the set and forget mentality, or keep it away from the view of the public. So green infrastructure and multifunctionality allow us to highlight the natural systems.
Yeah, and one term I want to point out that Ryan keeps saying rainwater, and that's a philosophical decision we made as a design firm years ago, and that our goal is not to deal with stormwater, but is to keep rainwater. And when you start looking at how much land it takes to do green infrastructure, or where green infrastructure can be folded into other land uses, it really makes sense to look at a multifunctional solution versus just here's the detention pond over there and then the park is on the other side of the site. Instead, why not make that into a single multifunctional facility?
Yeah, we'll see how well I can keep up the stormwater versus rainwater terminology. But so it's interesting that green infrastructure and multifunctionality overlap really well in parks. There's a symbiotic relationship with parks and green infrastructure. Parks are often where natural systems are still evident within the city. And that's where a lot of people often go to connect to those systems. Also, parks are a public amenity where the public can enjoy this. So there's a relationship there that seems to work for parks. Streetscapes, I think streetscapes are also public areas as well, and they are, when green infrastructure is adjacent to drain inlets within streetscapes, that's convenient and helpful. With sewer separation projects, I've done several of those, and they require expansive areas of streets to be removed and replaced, and often a cost-effective opportunity comes when you replace those streets with some portions of green infrastructure. And then new commercial and residential developments, often the regulations require that, and it's with new building that the opportunity exists to incorporate green infrastructure and incorporate additional functionality within those landscapes.
Yeah, and just one thing I want to touch on quick is sewer separation projects is an issue in Omaha, and I know it's an issue over in Des Moines and a few other communities in Iowa, where originally they had a single combined pipe for sanitary and storm. We've been able in Omaha, using our parks and our sewer separation projects, to literally save tens of millions of dollars using green infrastructure, which goes into a multifunctional landscape. So that's where we've really been able to test this concept and to put it into use.
So there's several green infrastructure practices, and it's interesting if you go through each one and just analyze each one, almost all of them naturally are multifunctional practices themselves. If you look at bioretention, it's a landscape bed, but it also is a stormwater practice. If you look at porous pavement, it's acting as a pavement, a transportation corridor, and it conveys moderate amounts of stormwater. Green roofs, the same thing. It's providing, it provides heat. It it helps with heat island effect. It beautifies the urban landscape, and it provides stormwater, water quality, and detention benefits. And then you can go through the rest, all of these different ones. It's interesting just how everything kind of works towards multifunctionality. So just some general multifunctional uses. So obviously, number one for green infrastructure is stormwater treatment and flood protection. But on top of that, you can have gathering assembly areas, you can have recreation, education, interpretive areas, aesthetics and art, landscape buffers, and vehicular parking, and there's more as well. But those are generally what you can add as far as function within these landscapes on top of the stormwater. So some examples of multifunctional landscapes. So starting with a single facility or a stormwater facility with a single function, it doesn't give us very much as far as function. It's a large expanse of land that's used, and it's not very aesthetically pleasing, and we can usually do better. So this landscape, it's it provides a focal point. It's aesthetic, and if you think about it, if you were in this landscape, it provides some restorative benefits. There's lots of different opportunities to provide several different functions. Also, this particular landscape provides a focal point within the environment. This next one, it's interesting how green infrastructure can soften the expansive, hard landscapes that we have with all the concrete. And I really like how this picture shows that you have a pavement there that's really softened through the green infrastructure, and creatively softened. So streetscapes elements can provide a reduced crossing distance for pedestrians with the bump outs. It increases safety. It obviously reduces heat island effect. It adds aesthetic beauty, and it can enhance a sense of place. There's some places where the sense of community has been lost, especially through transportation corridors. Streetscapes can provide that. Green infrastructure streetscapes can provide that as well. So within recreational landscapes, there's several different types of landscape. Several types of things you can do within a recreational landscape. So active or passive recreation. So you can have sports fields, you can have active or passive sports fields, wildlife observation, walking or biking, fishing, canoeing, and the list can go on.
And really, when you think about that, if you think about river corridors, all these recreational activities occur within them. Having grown up in the Midwest, like probably most of you, I mean, the place where all the action was along river corridors, and that's where we biked and fished and canoed and did all that. Those areas also were good for sports fields simply because they were level and they had good soils to support sports turf.
So this is one of our projects. It's Spring Lake Park, and it provides several different benefits, but it's interesting that one of the things that I didn't think about so much, but it's become an educational and an interpretive landscape. There's several people that have used it for education tours and places for the schools to come down and use the facility. I'm just surprised sometimes that as you build on different functions and as you functionally layer them within a landscape, additional benefits and functions often surface. So this project is, it's in Fargo. It's called the Fargo Project. It's an 18-acre detention facility. It's essentially become a community asset. So it's got trails, volleyball courts, a sculpture garden, wildflower garden, amphitheater, some orchards, community garden plots. They use all of it, and yet in the bottom right there, you can see that it fills up all the way for large storms. So an interesting way for a very large expansive landscape to be used when storms are not, when stormwater or rainwater hasn't been inundated into the system.
Yeah, and one thing I'll say about this is the reason that this is such a diverse project is the people that planned it did an extensive amount of community engagement as part of their process. This area has a lot of immigrant families that live around it that are within walking distance, and they actually engaged that group of folks to get the idea of adding things like community gardens and orchards. And so it wasn't just a landscape architect or a park planner or somebody sitting in their office alone, but this is actually the result of an extensive public engagement process.
So this is a campus at the University of Vermont. So obviously you can see the amphitheater in the front, but it's not just an amphitheater, it's an artistic piece and provides somewhat of a gateway into this dormitory area. And so it's providing several benefits, and it's quite artistic in its nature. And I think it's a good example. So this is a forested landscape, so green infrastructure can occur within forested landscapes. This particular picture is of Spring Lake again in a different area. The limestone you see in the front is a rapid infiltration trench or infiltration basin, and that this part of the project was brought on because we didn't want to extend a pipe through the forest, and so we took about 4 acres of residential runoff and brought it to this area, treated it upstream, and then we infiltrate it here before it goes and provide a level spreader over the berm there in the middle. And since we've had this installed, I don't think we've ever seen it actually go over the level spreader, which is...
And what's interesting about this is the lake that you saw the picture of a few minutes ago would be to your left of the screen, and it's about 60 feet lower in elevation. So it wasn't just having to go through forest, it was having to transverse a very difficult construction situation. So we not only saved a boatload of money, we preserved the forest as well. And a lot of times, people will walk past this and have no idea what it is, but it just adds another feature to the landscape.
This is in Georgia. It's called the Historic Fourth Ward Park. This is kind of green infrastructure to the hilt, and this is a very large detention facility with a walkway around it, with amphitheater, and with lots of interpretive elements within the landscape. It's kind of, it was very expensive, but it was still less expensive than the alternatives, the gray infrastructure alternatives that were offered. So it's interesting how it's interesting to see how a landscape can be opened up to the public and all of those amenities provided when the alternative would be just to hide it all beneath all of that money you see there being hidden under the ground, and now it's being utilized by the public.
Yeah, and I want to give a shout out on this to our friends at HDR, which is an Omaha-based engineering and architecture company. The thing I want to point out is they are very much a multidisciplinary firm, and having worked with them, I can tell you that it was both their water resources engineers and their landscape architects that really came up with this final product, or project, I should say. And as Ryan said, it's really a space that can be used by the community, enjoyed by the community, and become a point of pride for the community rather than just building a big structure that's underground that has mowed grass on top of it. So HDR did an outstanding job on this project.
Okay, ecosystem services. So ecosystem services are essentially the many benefits that humans gain from the natural environment. So most of the ecosystem studies that we have were focused on trees, and even with just that focus, the cost benefits of the ecosystem services shown for green infrastructure is pretty amazing. So within ecology, usually those ecosystem services are divided into 4 different categories: regulating services, cultural services, production services, and supporting services. So I've listed all of those services that we benefit from green infrastructure within each one of those divisions. And we're not going to go through them all, but it's interesting that normally for stormwater facilities, the only services that we normally design to are 3 of them: the water quality, erosion control mitigation, and hydrologic regulation, and sometimes flood protection as well. But it's interesting that when you go from single functioning stormwater facilities to green infrastructure, all of the additional benefits that can be acquired. The other thing is, this is a Bill Hunt principle. He has said that all green infrastructure practices are creative ecosystems. And it's kind of interesting. You've got a bioretention garden and a green roof, constructed wetlands, and daylighting streams. They're all created ecosystems. So on to economic benefits. So we talk about the triple line a lot. So the triple bottom line is going back to the EPA definition, the ecological, social, and economic dimensions of performance for a project. So green infrastructure multifunctionality is right in line with the triple bottom line. That's how, if you look at green infrastructure in that view, it aligns perfectly. So even without that view, green infrastructure projects are often sold or compared and still win out. But if you look at them with the triple bottom line, they're almost always going to win out over a traditional stormwater design. One thing that we've learned through several projects is that funding follows great design. So when you have a really good design, people get excited about it, and it's easier to get funding for it. Also, this study that EPA did, that they found that you could charge up to 28% premium per plot for properties located next to a water body. There are a lot of economic benefits that have been documented. So here in the city of Omaha, we have the sewer separation program, or
Clean Solutions Omaha.
Thank you.
Which is the same initials as CSO, which is combined sewer overflow for those of us in the engineering design field.
Yeah. So on the front end of their program, it was interesting that green infrastructure was essentially an afterthought. But as they got into the analysis of several projects, they found that they could save an enormous amount of money by utilizing existing green spaces and integrating green infrastructure into their program.
And like at Spring Lake Park, the project that Ryan has shown you a couple photos of, there we spent, or I should say the city of Omaha spent $3 million on green infrastructure, which eliminated $6 million of gray infrastructure. For 70 years, people have said, where's the lake in Spring Lake Park? And we actually put that lake back in. By doing some hydrologic investigations, we found out there were springs there that would give us a base flow for the lake. And we really just used the stormwater flow as kind of temporary detention. So it really is an interesting process. In other parks in Omaha, we have added new wetlands. Existing small park lagoons have become larger lagoons. And in all cases, because of looking at a multifunctional use for those sites, those parks are enhanced. There's more ecological services coming out of them because there's larger areas that can serve different types of habitats. And then the last thing, it's enhanced the quality of life for the people living around those parks. Elmwood Park is again a project we did. There we saved $600,000 by not putting a big pipe underground, but instead using a natural unused ravine as a cascade down to a creek. And Ryan's going to, I guess, catch that at the end of the conversation. But there's just some tremendous cost by saying, how can we be creative in marrying green infrastructure, and in this case, sewer separation projects.
And a quick analysis that I did of the green infrastructure within the whole program found that green infrastructure construction costs represented less than 0.2% of the whole program costs. Yet, with that 0.2% of construction costs, green infrastructure parks actively or passively manage about just under 5% of the entire combined sewer drainage area. And in storms, they possibly detain up to 11% of the sewer separation volumes. So the bottom line is not a lot of money for a huge bang in this particular situation. And a lot of this came through the collaborative work of the different departments within the city. And it was difficult for them to agree, but as they did, they had major benefits. So I'm going to go into a case study. This is another project that we did. It's called the UNO Welcome Center Garden. This project came about from a landscape architecture professor on the campus that came to us, and he pointed to this, where the arrows are, to this little cattail basin, and he said, we can do something better. Why don't we just take out the cattails and put in some amended soils and put in some bioretention plantings, and it'll be just so much better that way.
And just as a little preface on why the cattails were there, the university had renovated their welcome center, which you'll see in the background of the next photos. And one of the requirements they had to do is they had to attenuate their stormwater or mitigate their stormwater. And so the architect's solution was simply to pipe it to a hole in the front yard. And I'm not sure if they planted the cattails or they came by themselves, but I wish we had a picture of the cattails in the summer because you couldn't see the building. They were so big. So let's go to our next photo and we'll see that.
So essentially, this is kind of what the idea was, is to remove the cattails and put in some plantings and maybe an interpretive panel with a concrete pad there. And so we took the opportunity to kind of expand on this, and we took it from the cattails to a real integrated landscape, and we were trying to think about the different functions that would work in front of this building. This is the Welcome Center, so there's a lot of opportunities that just come from the name of the building, right? It's the front entrance of the university. And so we looked at the opportunity and tried to expand on it. So this is another view of the landscape there. So the landscape includes seating areas, resting areas, viewing areas, boulders to climb on, different ways to get around the landscape. And it includes a lot of different types of plantings that the landscape professor helped us with. He wanted to make this an educational facility after we expanded the idea of what this landscape could be. And this has truly become an amenity for the university.
Yeah, one thing about it, and I think we should give Steve Rohde, Professor Steve Rohde, who's with the UNO Department of Biology, also taught in landscape architecture at UNL for a while, really credit for having foresight here. He saw this as not only the welcome garden to new students on the university, but you can see some dormitories in the background, that this could be a place where students could hang out to talk or to study. Steve also had the foresight to say, why can't we use woody plants within bioretention? And at that time, we were all just kind of looking at herbaceous plants. So we actually have trees and woody shrubs and everything within this. One thing you learn over time is that some ideas are not great ideas. And right in the middle of this picture, you see a little lawn area. That was buffalo grass. We put that in, and it struggled for 4 or 5 years. And just recently, it was replaced with a dwarf fescue, a tall dwarf fescue, a dwarf tall fescue. Sorry, I always get that mixed up. Grass. Which is a very low input grass, but actually is doing better. It's preventing erosion, and it's really better suited. So one great thing about green infrastructure is if you do these projects, go back and look at them each year, and you'll learn a lot of lessons from that.
So this is the plan view of the design of the project. So it was essentially 2 circles and somewhat, it was artistic, but the idea was we had 2 inputs as far as runoff, the rainwater coming into the site. So we utilized it for a side-by-side comparison of 2 alternative bioretention prototypes. So we did, one of the under drains was lower with an elbow, and the other one wasn't as low, and we were just trying to allow for future educational opportunities to really explore this as an outdoor classroom. The area gets used as a study area, a gathering spot, and really it's a welcoming landscape into the whole university, and it's a refuge from a lot of the parking lots and other areas of the university. And it's beautiful, especially with Steve's rich plant palette. Yeah, it's really a nice area with a lot of visual interest. So really quick, just to compare multifunctionality in economic terms. This is a very simple comparison, but this is essentially what the project construction costs were broken down. And it's not so important to see all the individual descriptions here, but just notice that the total cost was about $52,000. So if this was only an outdoor education area, it'd probably be just about $34,000 to build that as a single function landscape. As a stormwater treatment only, it would only have cost $24,000. So if you were looking at this from a stormwater water quality point of view, you would have said, well, $52,000 is really expensive and it's probably not worth it. But from a multifunctional point of view, it's very different. So if this was an outdoor assembly area, $33,000, a landscape buffer, only $21,000. So looking at all these, so if we total all of the single functional landscapes, if they were built separately on this campus, they would be at about $112,000, but the project was only $52,000. So if you look at it in a different way, so if the storm treatment only was about 23, as built was about 52, and total project value, you could say, would be about 113 or so. So it really just depends on how you look at it, and if you include the economic benefits of those additional functions that you add into the landscape. And some of the other lessons that we learned was multifunctional spaces create synergy. And then you can make these spaces artistic, aesthetic, and economical. And then in this case, we communicated early the design ideas, and they drove the project in a very different way than they could have. And so trying to keep options open and communicate early are important with green infrastructure.
Yeah, and one thing on this project, just jumping to community engagement, because this was a university campus and our funding was from the city stormwater program, we didn't have to have a lot of community engagement. Maybe we should have. We would have got more ideas of what to include in the project itself. But in this case, we really had the stakeholder group, which was the university facilities group, and then we had Professor Rohde, who had certain research needs. And then actually our funder, the city of Omaha, took a real active role in commenting on the design, not driving the design. Ryan really did the design. But here my point is that your project community engagement is going to be based upon who the stakeholders were. This was a simple project, and I mean, we were just kind of singing Kumbaya with all three groups during the entire project.
Even though we expanded the budget, but I think we doubled the budget of what they were expecting.
Well, and I wouldn't say expecting, but I think their initial thoughts were, but what was great about this is we kept saying, and we can do this, and we can have an outdoor learning area, and we can have an interpretive exhibit. With all those ands, they saw us building the case for multifunctionalism in this site. So rather than simply being a garden that deals with stormwater, it's a student gathering spot. And that's what got people excited. That's what got us the funding of $52,000 versus the $24,000 to build the site. And it really has become a place of pride for the campus. So it really goes back to that triple bottom line that Ryan spoke about, and just community pride. So let's.
Okay, on to innovation and creativity. So working with nature should be inspiring. It's innovation isn't inventing new practices. It's most innovation within green infrastructure includes better integration of the principles we learn from the natural systems themselves. The other thing too is, as the public understands what green infrastructure can be, they're going to demand better design, and we can do that through innovation and creativity and keeping our options open. And as far as hybrid solutions, not all projects or sites can be designed solely with green infrastructure, so hybrid green and gray designs should be part of the creative mix of the solution. So one thing that I do when I look at a green infrastructure project is try to identify the single functioning structures. So the pipes and the manholes and the catch basins, and see if I can eliminate those or reduce them. And then instead of those pipes, manholes and drain inlets, increase the pervious surfaces, use infiltration practices or swells and channels. And sometimes you can get a site without any stormwater with very few pipes and manholes. Another thing that helps with creativity and innovation is taking storm flows offline. Offlining opens up lots of opportunities for creatively integrating green infrastructure into the storm system. If you're not familiar with offlining, so in this diagram, you have the back of curb, the gutter there, and so you have a flow coming from the left to the right, and as you have rainwater fill up the rain garden, it goes into the rain garden, and then if the rain garden is full, the flow continues into the drain inlet. So what you do there is you reduce the velocity and the interruption of the water. And so obviously you use a curb cut, and you can use lots of different ways to offline things, but that's one of the main creative design principles that really help with designing.
And one thing that's great about this is this doesn't have to involve a lot of new construction. You can literally go out with a curb grinding machine, grind that curb 3 or 4 feet upstream from the drain inlet, and maybe that curb cut is maybe 18 to 24 inches wide, and then you just simply have to excavate behind the inlet itself. So this is really low-hanging fruit, easy to accomplish green infrastructure that creates kind of a nice little pocket garden along a parking lot near a storm drain inlet.
So really quick, I just wanted to mention some cases of over-design. So we do need to include safety, but keep in mind that safety factors can conflict with cost effectiveness. So some projects have been known to be over-designed due to lack of design and not because it was designed well. Going on to the vegetation point, often if you're really trying to get a lot of green infrastructure into a project, you can fall into the trap of infiltrating too much rainwater before it actually reaches the plantings, and then you're actually suspending these plantings in very porous soils and drying them out and killing them by not providing them the base flows that they need. And then so splitting or diverting flows, they're a good way of reducing or deterring over-design by controlling levels of water within a system to prevent excessive erosion control, reinforcement, or larger structures. So this is just a quick application of a few principles. This is somewhat of a whimsical concept design. It's not implemented, but just in this case, we have several. So the design includes a building. This is a commercial building in the red, and the green on the top would be a green roof. But if you notice that the arrows show 2 different stormwater pathways. The one on the left would include taking off the runoff from the road and treating it within a pocket wetland on the side there, and then draining it through the parking lot towards the bottom there. And then the other stormwater pathway would be taking roof runoff, putting it into a cistern, then into the overflow, go into a bioretention cell, and then through several runnels. So just this is just kind of expanding what creativity could look like within a site. This is just the parking lot. So just notice that the parking lot could be truly green. It could be made of permeable pavers and then turf grass in the green there within aggregate containment systems. And then areas where you don't expect people to park often, you could even put native grasses within the containment systems and create a truly green parking lot. And this just shows that there are lots of trees in this design, so you could locate trees near to pavements through soil modifications such as structural soils, and this can maximize your space and add the ability to shape the landscapes around parking lots and other pavements. So lots of opportunities that I don't know if we fully have explored within our actual landscapes. So going on to integral design and collaboration. So we already discussed that green infrastructure essentially integrates and includes things versus gray infrastructure often separates and excludes things. Transdisciplinary collaboration. Green infrastructure falls between several different professional competencies. There's water resource engineers, civil engineers, landscape architects, soil scientists, geotechnical engineers, environmental engineers, community facilitators. It goes on and on and on. There's probably no single profession that's well suited to design green infrastructure by themselves. So design teams should cultivate environments where they can explore out of the box ideas, they can share expertise and have true collaboration. And then coordination, obviously that goes with the collaboration. Almost always, often you'll have, especially with larger projects, several stakeholders, and aligning goals, budgets, timeframes, and responsibilities is important in the process. And the last bullet there is long-term and strategic planning. This is just to say that green infrastructure, if it's going to be part of a project, needs to be placed in the design process very early. So quick, just a thought about underground storage. Underground storage is a valid green infrastructure practice. I wouldn't call it the best, but it's valid. There are times when designers use this as a cookie cutter go-to design option when other better surface green infrastructure practices could be used. So we shouldn't use underground storage as a fix-all solution because it still conceals the treatment, and it can be valid in a hybrid solution where you need to provide a lot of storm volume, but still try to incorporate other green infrastructure practices.
Yeah, and if you look at this slide, you see the plastic half-round storage chambers. Those are made out of petroleum, or those were made from petroleum. Those were trucked several hundred miles to this site. The stone that you see them putting in is a crushed limestone, so a lot of embedded energy in that into just producing the stone, which was then transported about 50 miles to this site. So if this is your only option, it's a good option, but if you can look at surface options, they're going to be a lot more cost effective.
Okay, so this is a case study in Georgia. This is a real project that was actually done with traditional stormwater systems. It's about 35 individual buildings with 80 units. It was built in 2007, early in my profession. So what I did is try to evaluate several different green infrastructure practices within this and see possibly as an afterthought what would have been the best options. So really quick, this site works well because it's a long rectangular shape with long pipes. It had an end of the pipe solution which required a large retaining wall. It has pretty good soils, and the regulations required a decent amount of green space. So this is the site. It was built in phases, so this is the first phase that it was built. This is a slope analysis really quick, just so you can understand the site. The upper right is the higher area of the site, and lower left is the lower part of the site where the basin is located. So this is what was designed. The pipe system connected the right side to the left. and drained into this basin. And then you get here at the bottom, you can see an average 7-foot height wall. And then if you look really quick, the total pond storage required was 131,000 cubic feet. I'm not going to go through the numbers extensively on this. It's but just to look at it as a comparison. So this is the drainage analysis. The pink area is the area that drains to the basin. So this is the cost, the base cost. So this doesn't include the buildings or other utilities besides the stormwater utilities. It's the pavements, and the stormwater and the wall and landscape. So I analyzed the bioretention with as a hybrid with with the storm system, and then the same thing with pervious pavement, soil conditioning, and then as a last one, it was several different options with the bioretention, porous pavement, soil amendments, and the chamber system all together. So this first one is the bioretention. That's all the locations that we could cram bioretention into. And then you have a reduced storm system down to a reduced size basin. So the basin has a berm height of about approximately 3 feet, but the basin only has to hold 105 cubic feet. So, and this is the red areas in this diagram, and then show areas that were not treated by the bioretention based on the requirements for water quality requirements. So the cost analysis to the at the bottom around with the orange area, the bottom left is the total cost for the bioretention alternative. This also includes all of the stormwater, the storm system, compared to the base cost, which is about $6,000 more. So bioretention actually would save this project some money. So porous pavement. So if you put porous pavement on the bottom and left sides of all of the parking lots in the stalls, you would still need a lot of the stormwater piping, and the basin, you would still need a wall height of about 2.5. So this diagram just shows some of the areas that were not treated by the porous pavement, the areas in red. And so this is the other cost comparison for the porous pavement. This actually is about $20,000 less than the baseline. So we're getting better along as we go. So soil enhancements. So you add soil enhancements to everything. The storm pipe still remains. You still have a wall, but you don't have as much cost because the soil enhancements are not that much. You still have to treat quite a lot because the soil enhancements don't actually treat a lot of the impervious areas, but the cost, surprisingly, is much cheaper. So in this case, it's over $30,000 of savings from the base cost. And then finally, the multiple alternatives. You add the soil enhancements, the bioretention, the pervious pavement, and then the reduced stormwater, and you get a lot less storage required, and the berm wall is much smaller, so you get all the benefits, and then everything gets treated, but the cost is a little bit higher than the baseline. So side-by-side volumes, probably not important. I went through all the numbers very closely to try to compare things and to compare them equally. So here's all the volumes. But probably the most takeaway here is the side-by-side costs. So if you look in the red, the bioretention saves about 6,000, porous pavement about 20,000, and the soil enhancement alternative is almost 33,000. So I think the takeaway here is that each project's different, and just going to the cookie cutter solution doesn't always make sense, especially when you're integrating green infrastructure practices. And another quick case study is this Elmwood Park diversion that John mentioned earlier. This project just shows how there was a lot of out-of-the-box collaborative thinking to provide an innovative solution. So this is a sewer separation project, and the yellow is the project boundaries. Most of the sites slope to the upper right, but we were able to divert 30 acres of residential drainage to the bottom there through the Elmwood Park diversion there.
And Ryan, why was this the most important project in Omaha's CSO program?
Well, it was about the first.
Well, no, it's
so
about
it set a precedent.
Yeah, it's actually my neighborhood. I live right about where it says natural drainage path. I live right about where the top of the blue is.
That's correct. So John was very instrumental in a lot of this.
Yeah, the other thing that's interesting is this watershed, as it's going up to the upper right, gets so flat that we literally could not get enough pipes in the ground on 63rd Street, where the yellow line is on the far right side there. We couldn't get enough pipes in that right of way to convey all the water because of it was going to kind of back up due to the flatness of the site to the west. So we really did need collaborative thinking. This was fun because it was my neighborhood and I got to do the community engagement on it. And we had a very active group of people that were interested in the project, and they hung on with us for the entire project.
So this is just a conceptual diagram of the solution. So we came up with 7 different drop-down structured concrete weir structures to bring the diverted stormwater or rainwater down the heavily sloped valley there. So as I said, so these weir structures were really quite a challenge to size and to get right. And it was a transdisciplinary project between the water resource engineer, the structural engineer, and the landscape architect. We had a lot of back and forth between the sizing, and we eventually decided to have a bypass pipe underneath all of these drop-down structures. So you can see the white, that's the bypass pipe that was eventually put in to allow us to have a little bit smaller structures and to protect the bioretention that was placed in between some of the weir structures.
Yeah, and at first I had heartburn with this underground pipe, but really what we were trying to do with this project is we were trying to run 22 cubic feet through the above ground features for a water quality benefit. And then once we exceeded that, then the additional flow goes through the pipe. But as you can see, that pipe that's on the left side comes to an end and actually surfaces in a pond. That water flows into that pond, and then at a certain point flows into the pipe that's to the right that goes down to the creek. So even the massive large storm flows are going into a detention pond where we have an opportunity to do some water quality improvements with them before they exit to the creek.
The other thing is this project, some of the goals were to minimize the tree loss and integrate the green infrastructure practices into this unique, beautiful park. And so that was part of the challenge there. This is a pre-development project photo. And just look at all the trees. And then this is just after it was developed. You'll notice that we added several trees, but didn't take very many out. So pre and post. So we were able to both maintain most of the trees within this valley, as well as truly integrate it well within this valley. And I think it turned out pretty nicely. So this is the one thing that I didn't mention is we integrated some bioretention cells in between those weir structures. So in this photo, you can see the gangly vegetation up there that's kind of dead. This is in the winter. That's a bioretention cell where the water comes around that berm, the yellow berm there, and comes up to the wall and then backflows up into the bioretention cell. So it's offline is what we would say, and then the main water flow goes over the weir structure.
Yeah, so it's a great example of even having kind of multiple functions in the channel itself. So with that, we've talked about a lot of projects, and you've seen a number of different ways that you can do multifunctional projects. But the thing that's important in doing those projects is you need to build support for them. And so with community engagement, typically we talk about defining the message, but a question I'd like to ask you is, are we defining the message, or are we asking for input? And the question that I often ask clients when they say, oh, we want you to help us on community engagement, is I say, well, do you want community information or engagement? And then the next question is, who do you want to inform? Is it stakeholder groups that you have identified, or is it just members of the public that are going to show up because they find a flyer in their door, or they see something in their neighborhood newsletter? And a lot of times we'll spend a lot of time just trying to identify who the people are that we want to engage. And then it gets back to that question I mentioned a minute ago, and that is how are we going to engage them? Is it just informational? Is it just to say, hey, we need to put a new sewer line or water line down the middle of your street, and here's what's going to happen? Or is it more like the projects you've seen with Spring Lake Park and Elmwood Park, where we really wanted the public's ideas? And there we wanted their input and we wanted their ideas. And one thing I will say as a landscape architect who's practiced a lot of years is that my clients have given me more good design ideas than I ever came up with on my own. So that's important to really understand. Is it just informational? Are we just telling people what's going to happen, or are we saying, hey, this is what we need to do, what are your ideas about it? And then the third thing is, and this is a thing on some city projects or governmental projects, are you doing the engagement for meaningful interaction? In other words, I want information back or ideas from the community, or are you just doing it to check a box? If you're just doing it to check a box, I understand that, but I think you need to tell the public that, because if they think they're going to have a lot of input and you just are needing to say, yep, we did a community meeting on September 11th, 2018, you need to say that at the beginning of the meeting. So when you do community engagement, it's kind of like writing a invitation when you were in second grade. You had to learn the whats and the wheres and the whos. But, you know, explaining what the project is, what the extents of the project. People always want to know who is sponsoring the project, but honestly, if you work for government, you know that people don't understand the difference between, in our case in Nebraska, the natural resource districts and the city or our state park system. So a lot of times you have to explain, you know, why the project is needed. In the case of the natural resources districts, one of their mandates by state statute is to improve water quality. So that's something we would say. The NRD, who covers several counties, is doing this because they are mandated by state law to do it. The thing that we do too often in public meetings is we don't talk about benefits. And that's what was great about doing Spring Lake Park, because we said, we're going to help you, the neighborhood, who for 20 years have advocated for a lake to go back into Spring Lake Park. We're going to help you create that lake, and we did. And it's just amazing how your stock and your client stock, if it's if you're city government or whoever, how much your stock increases in value in the eyes of those community members if you help them get something they want to get. And that was just a great process. The last thing that the astute people, and maybe they're going to be the grumpy people, are going to ask is, well, what's it going to cost and who's paying? With the Omaha Cities Combined Sewer Overflow or Clean Solutions for Omaha program, we have to go to public meetings and explain to the people in the room that they are the ratepayers. They are paying for this federally mandated improvement in water quality. Philosophically, I really disagreed with the city in that they called it a unfunded federal mandate. Lots of things are unfunded. I always just said it was a federal requirement we needed to meet. But we were upfront with the people saying the people that are going to pay this are the people that pay the sewer taxes, which are the citizens of Omaha and our surrounding communities, because we have combined wastewater treatment facilities. So community engagement, what are the 5 key concepts? Well, here's what I have found from about, again, 35 years of practice. And I'm going to go through these, but the thing that's important is that you really go into the meetings organized. You want to have an agenda. You want to tell people what the agenda is. You want to respect the people in that room. At the end of the night, my goal is not to have everybody like me, but my goal is to have everybody respect me as a facilitator or a community engagement person. And let's just kind of go through some of these in some detail. So in my opinion, if you think community engagement is once and done process, you're probably not going to do it successfully. Typically, we have a series of meetings with each project, and in those meetings, we go from kind of wild-eyed ideas down to the design being refined each time some more, and we also remind them what we talked about. So we'll have meetings during the design phase, and then especially with our park construction and our sewer separation projects, we have a meeting at the beginning of construction to tell people what's going to happen. We often do construction updates. Those can be newsletters, they can be emails. But the one thing that I want to tell you, for really successful community engagement, you need a contact person for the project. You don't want to give them a list of five email addresses and telephone numbers, but you want one name, a telephone number, and an email, hopefully. The thing we found is that person needs to be a person that likes to work with people, and that's really important. So again, I talked a little earlier about making it meaningful. You really need to tell people what you want from them. Are you looking for their role, or are you just looking to provide them information? We always explain the engagement process. In other words, it's going to be a series of moving processes. But another thing we always do is we say, who's going to make the decision? A lot of times people come to a public meeting, they think at some point in that meeting they're going to put their hand up and vote, and that's what's going to happen. And I can tell you from working for all levels of government for 3 decades, that isn't how it happens. But you can talk about how their involvement will influence that decision. And then the last thing is I had a boss who used to say, you better wear iron underwear to public meetings, and I don't know that I agree with that or disagree with it, but I think you have to be respectful of people, whether they like your project or they don't like your project, but you've got to let them speak. Here's something that I learned very painfully over a lot of years, and that is you need to value people's time, and you need to tell them you value it. We always have a set starting time, we have a set ending time. We say at the beginning of the meeting, hey, it's 7 o'clock, we're going to get started. This meeting is going to be done at 8:30. Why is it going to be done? Because I respect your time and I appreciate you taking time out of your day to come to this public meeting. We will often ask everybody who wants to speak to put their hand up so I know who in the crowd wants to speak. We also will set a maximum time. We'll say everybody can have, okay, we have 45 minutes, we have 15 speakers, everybody can have 3 minutes, and then we time them for that 3 minutes. And then the last thing you need to do, if you're the facilitator, is you need to manage your meeting firmly and fairly. And one thing I will tell you is, based on who your audience is, that firmly and fairly changes. If you are in a meeting that is primarily Anglos, that will be one set of firm and fair. If it's an integrated group with African Americans and Anglos, that will be different. And so all I'm just saying is there isn't any right or wrong there, but it's important that you understand that and that you provide firmness and that you keep the meeting moving, but you're also fair to everybody in that room. Another thing that is important is tell them what you know, but also tell them what you don't know. And if you don't know something, say, hey, I don't know that, but I'll find it out. The other thing is avoid jargon. Don't talk about storm events. Talk about rain or rainstorms or whatever, but really try to avoid the jargon, because that really has people tune out pretty quickly. And then the last thing I want to tell you is that even if you have a meeting where you have people talk, there are going to be people who don't want to talk. And in this picture, you see a lady filling out one of our ever-present comment forms. We get great comments from those comment forms. A lot of the people that talk will fill them out. So that's important. Emailing is great. We promise people we will use their email for nothing other than contacting them about future meetings or giving them updates. And people are really trusting if you show that that's the case. We always have a project contact email. In some cases, that might be my email, jroyster@bigmuddyworkshop.com. Sometimes we set up a specific email for a project. We believe in concise, simple handouts. Those handouts, again, can have the contact information on them. And then the last thing is if you're going to have comment forms, go out and buy a cheap bag of pencils or pens, whatever you want, but provided, it's amazing how many people don't carry pens and pencils with them, but you can solve that very quickly. So just kind of in summary, I can tell you from my years of experience that well-managed public engagement processes create better projects. You will get amazing ideas from the public. Now, the guy that wanted the 50-foot high waterfall on Spring Lake Park still is wanting that. It did not go into the project, but Jim and I have become friends, and every time I see him, he kids me about that. I think the reason he does is when he was saying that in the meeting, I was being sincere, and I was being upfront that I thought it was kind of hard to do, but we'd look at it. And then the last thing is you really need to be welcoming of other people's ideas, and that simply results from you being open in a meeting and being trying to engage everybody. And then the last thing I think that really is important is, unlike this webinar where Ryan and I have been doing the talking, if this were a public meeting, we would have been doing two things. We would have been listening and making notes, and that's critical. But your projects will be so much better if you involve the community in them. Again, you need to do that according to your client's, wishes and requirements. But I really encourage you to do that. I say that I am never more pumped than when I'm going into a public meeting, which I know is going to be divisive. And the reason I'm pumped is not to beat people down, but to see how we can together as a group, and actually groups that are often divided, how we can create a common consensus to move a project forward.
So just as a summary from the multifunctional green infrastructure things that we talked about, so functionally layered landscapes provide multiple benefits. Those benefits often affect several stakeholders. Number two, allow green infrastructure to integrate versus separate. We talked about how single functioning gray infrastructure separates. So keep the integration and integration in mind. Also work with nature, not against it. Green infrastructure is about mimicking natural processes and following the cues from the natural systems that we have. Also, no person or profession has all the answers. Green infrastructure is by its nature a combination of several different systems. And finally, we need more sound creative design. I think there's a call for greater design. There's still a lot of innovation and design progress to be made. So leave it there, and
Okay, are you guys okay? All right.